welcome to the first session of the inaugural Manufacturing Summit here at Mobile World Congress. We're really delighted to welcome you all, and it's great to see you here first thing. So this first session today is going to be looking at advanced analytics and robotics in manufacturing. And to open the session, we're going to have a keynote from Guan from Accenture. And then following that, we'll be joined by Groote from KPN. And then we'll be finalising this session with a panel comprising of ABB, Cognite, Teradata and Vodafone. And Lan will be joining back to moderate that panel. So we've got a packed agenda. And without further ado, I'll pass on to Lan, sorry. And yeah, please enjoy.
Hi, everyone. Good morning. I'm Lan. If I ask you who are icons of AI in manufacturing, your immediate thought may be of leading tech giants like Tesla's Gigafactory, Amazon drones, or smart warehouses. But let me offer a very different example today. Have you ever wondered how clay is turned into a ceramic toilet? Today, I will start by sharing how AI has changed the face of manufacturing in a very traditional industry where a century-old craft is made. So this story is very close to my heart because the transformation happened in the place where I grew up in China. Much of the grueling technical work has been replaced by robots. Glazing is the process of applying glazed slurry on the surface of a ceramic, a shaped ceramic. Since ancient times, brushes were used. And the hazardous glazing process can cause disease in workers. Now, the glazing application robots have taken over. These robots can spray the glaze at 3 times the efficiency of humans, what humans can do, and also with 100% uniformity rate. Handling and palletizing robots can move these 100-kilogram toilets across the production floor with ease, which typically takes 6 to 8 workers. High magnification cameras also perform quality checks of all these toilets on the operating tables with, within 35 seconds. As what you saw earlier, hundreds of advanced guided vehicles, AGVs, zipping around. They have replaced the fixed conveyor system, letting the plant reconfigure the flow of its products and components seamlessly across different workstations. Just to put the cherry on the top, the entire production floor is retrofitted with 1,000 sensors performing high bandwidth, low latency data transmission in a 5G plus environment. So what's the takeaway from this story? To me, this story manifested several priority areas of AI evolution in manufacturing. Let me break down how Jomu did it and how other manufacturers can adopt it. There are 3 stages of AI evolution. Okay, so let me start from the first one. First and foremost, intelligence of a single device. This is the new glazing master in my story earlier. So as manufacturers can spring into the era of AI by enlisting robots to do all kinds of repetitive tasks, like welding, painting, lifting, palletizing, or assembling heavy objects. But there's so much more these robots can do. We should look around the factory floor and ask ourselves the questions, are there more sophisticated, highly variable tasks that these robots can help with? Agriculture is actually a very good example where robots can adapt to part-to-part variability. In Japan, these robots have demonstrated ability to cut down the time required to harvest strawberries by up to 40% using stereoscopic imaging systems to evaluate the ripeness of the strawberries. In jewelry industries, robots can take on tasks like cutting precious gemstones, which previously were done by highly skilled craftspeople. But for a truly smart and digitized factory, we need authentic intelligence. That's the second stage. So what do I mean by authentic intelligence? This is the robots as your line managers making unbiased, fact-based decisions. For experts in lean manufacturing, I'm sure there are a lot of them here, this is analogous to lean methodology, whose three key goals are improve quality, eliminate waste, and maximize productivity. So we should start to see robots working together, sharing data from force sensors, collision sensors, all kinds of sensors, such that managers can make informed decisions with true authenticity. So let me give you a better understanding of what this means. To me, the first point is catch when it breaks. This is all about improving quality. Deep learning models can perform quality control, so they can proactively identify faulty products to reduce the false error rate by up to 90%. Predict when it will break. That's the second stage. This is all about eliminate waste. The unplanned downtime in manufacturing is estimated to be about $50 billion annually. IoT sensors can monitor patterns and give insights into wear and tear, as well as unexpected issues to do predictive maintenance. Also, we should think about how to break glass and produce more. This is all about maximizing productivity. Control Tower AI can scan the entire production floor, identify the inefficient part of the process, manufacturing process, and offer recommendation to speed up production, and also while also cutting costs. So if we all think of the role of AI in the lens of lean manufacturing, these robots are no longer being seen as expensive toys. All right, let me introduce the final stage of evolution, which is augmented intelligence. These are robots becoming your journeyman. So when we combine the brute force of machine-centric artificial intelligence and the creative power of human authentic intelligence, we will get augmented intelligence. That is quite a mouthful. So have you ever thought about AI robots can actually be our eyes and ears to do sensing, understanding, comprehending, and even reasoning? With 2D and 3D machine vision, these robots can develop a lot of mobility and dexterity to complement tasks performed by human teammates. Also, imagine advanced mobile robots, AMRs, navigating the entire production floor efficiently, using visual data to offer recommendations, to navigate, monitor, and supervise the plants, so that they can sidestep human workers and they can pass tasks back and forth with human workers. So helping robots see and hear, so they can work side by side with human workers, they can pass tasks back and forth. Isn't that a cool, very cool production scene that we have all dreamed about? Okay, so why haven't we done all this overnight? What are the typical gotchas? All right, okay, so what are the typical gotchas? Let me talk about a couple of common challenges. The most fundamental one is data. The most common challenge to get right is data. Volume, velocity, and variety of data being produced on the production floor is quite daunting. So how do we effectively take advantage of them? This is not your traditional data across other business functions like finance, marketing. We should start thinking about how to collect and catalog this specialty data, including data from IoT sensors, data from programmable logic controllers, data from human-machine interface, data from advanced guided vehicles, and much more. The good news is there are a ton of technology partners already out there. They are taking care of the data complexity for us using sophisticated data ops platform, specifically designed for manufacturers. Essentially, data fusion capabilities to contextually stitch together IT and OT data so that manufacturers don't need to navigate in the dark. The second area needing attention is actually algorithmic architecture. Again, this is not your traditional legacy IT infrastructure revamped. So thousands of privacy-preserving AI algorithms, they can get compute-intensive very, very quickly. And also millions of sensors and devices transmitting data back and forth, and requires a cloud computing network with connectivity to communicate from edge to cloud, from distributed ground truth to federated learnings. I have to give you an example. Stellantis, Team Brazil, and Accenture are working together to build this private 5G network in Stellantis plant in the automotive center of Guan in northeastern Brazil. Specifically, Stellantis is using 5G and computer vision to capture images of a vehicle, a vehicle's movement on the production line. So with low latency and also high data threshold on the 5G network, they are able to perform real-time quality inspection of the vehicle. All right, so with so much automation benefits we talk about, we cannot ignore the anxiety of the topic of ethics on workers. There's no black and white answer, okay, in terms of a job impact. AI and robots have a very mixed effect. Conventional wisdom is telling us that jobs will go away when robots arrive. But it turns out in some situations, this labor-saving kind of tools actually lead to more work. In some cases, because of the human modeling, most other cases could be because of the new demands associated with technology. Oftentimes, it's because of both. So manufacturers need to, manage the impact of both ends of the spectrum, such that they can, reach the balance. They can be both commercially and ethically responsible. All right, last box. Is it too early for ESG? As with the shift to smart factory, I believe it offers an opportunity to align ESG goals. So wearables, energy management, software on the floor, all these are great tools to manage energy costs and reduce net carbon, to do the net carbon reduction. Let me give you one example. Schneider Electric's smart factory in Kentucky, United States, have actually integrated its IoT connectivity with smart meters. They are seeing enormous benefits in terms of energy cost reduction, net carbon reduction, and also water usage reduction. So embracing AI with ESG mindset has won Schneider a prestigious superior energy performance certification by U.S. Department of Energy. All right, so what will the future bring? There's no doubt that AI is changing the future of manufacturing, and some companies are already looking beyond the production lines. BMW, partner with NVIDIA, is building the first AI factory, virtual factory in the metaverse, way before any new parts rolled off the physical production plant, using the Omniverse platform. So it's super exciting. Unlike other types of AI that I've been talking about on the production floor, Omniverse actually allows the entire production process to be simulated with photorealistic details and grounded in the fundamentals of physics. The Omniverse platform also allows the avatars of human workers, simulate avatars of the human workers grabbing tools, parts, assembling, components, so that it can find the best procedure for their job and also minimize ergonomic problems and also help us identify the best number of workers for the job. So in summary, it's an exciting time. And with so much technological potential out there, it's easy for us to get carried away. So it's important for us to remind manufacturers that it's a balancing act. You really need to think about, do all these automation programs tie back to the original goals that you are hoping to achieve? Like I said, it's a balancing act between cost, time, degree of the digitization, but when it's done right, manufacturers can see manifold of returns on investments. This is also a prime time for traditional manufacturers to revitalize themselves. The risk of this kind of digital rollout, in my opinion, is a lot lower now. So if looking back the 5G ceramic factory example of Jomo, success wasn't guaranteed. Okay, when they actually started, when China hadn't even built the base 5G station, but they did it. So now, in contrast, sophisticated partners out there, they offer a full suite of options for us. I believe we will be hearing more remarkable, amazing AI in manufacturing stories like the 5G ceramic one within the next couple of years. And I have no doubt that every story will remind ourselves the industrial parks could actually be more exciting than amusement theme parks with power and wisdom fully unleashed from AI and robotics. Thank you.
Thanks so much for Guan there for opening the session and for the opening keynote. So for the next speaker, I'm delighted to welcome Groote from KPN. So over to you, Jakob.
Thank you, Joe. Does it work? Yeah, you can hear me? Good, good, good. What an audience. What a nice surprise to have so many people here at this manufacturing summit. And what good to see you all back here after 2 years of what was it? Hardly interacting, people not seeing each other through Teams, but then not knowing exactly how they acted, etc. So I'm really delighted to be here and give you a presentation about what we within KPN are doing with manufacturing and the like. And I'd like to build on Lan's story, but I'd like to also add a couple of other things to that. Because I think when we're talking about manufacturing and the AI side of it, the data side of it, it's also important to have the right interaction between the human and the machine. And that will play an enormous role in order to get these creativity and the brains all combined. But let me take you a couple of steps back. 10 years ago, I rolled out the 4G network of KPN, the Dutch incumbent operator focusing on the Netherlands. And then we were talking always about 4G, and we tried to sell 4G, etc. And we started to realize that not a lot of people really understood what 4G actually was. So it became very difficult to sell it. What became important afterwards, when we decided to roll out a 5G network, is not talk about all the technologies and sell technology, but try to find what is the value add. What are the good features of 5G which will add to the connectivity and which you could do? And that's why I set up a couple of field labs, 6 in total, 3 on this picture. But we also had a field lab in rural, in mobility, and also in the process industry with Shell refinery in Pernis at that moment in time. And what we did in these field labs is bring an ecosystem together of specific partners that could help out and find a solution for a real business problem. And that's why I always use that mantra, it's business first, technology second. So let's not only focus on the technology side, but let's also focus on what's the added value for the customer. How can we bring that ecosystem together? And a couple of value-added services were then raised on top of the 5G connectivity side. So everyone in the Netherlands got 5G, etc. But if they want to have specific features, they are going to pay for these specific features. And one of them is what we call application priority, which we are now rolling out through the Netherlands to connect emergency vehicles with smart traffic lights, so that they always get a green light, so that they can move fast to an accident or move fast to an hospital. And that's what we call always green for blue. The second thing is a guaranteed bandwidth in a certain localized area. Give people the bandwidth that they actually need. So if later on in the presentation you will recognize that AR and VR is extremely important, but you need some bandwidth for that. You need upload bandwidth and download bandwidth for it. So give them the guarantee that they can really rely on that, so that the business process of that manufacturer can be improved. And that's what we did in the Johan Cruyff Arena with all kinds of AR, VR solutions. And the second thing, and I'm focusing in more and more to manufacturing, is what we did with a robot. And this robot is now running all over the world using our SIM cards, but using the 5G networks in Australia, in Singapore, but also in the Netherlands, to really test the environment, drive autonomously, etc., with quite some success. Step back, but also focus on manufacturing. I call this the flywheel of manufacturing. And you see that data, like you said, Guan, data is very, very important. It's the core capability that needs to be in place. But if you have the data, you can really digitalize and integrate all kinds of value chains on top. But if you want to integrate, you need the connectivity. So you need a high quality connectivity for that. So 5G really comes into play and plays a very important role. If you then also take a look at where people are investing and which technology people are investing, you see high growth rates on the robotics side, but even higher on the AR and VR part. So it's not only robots, it's also what do people see when they are at different places. Also, real-time localization is extremely important, and we have to wait a little bit for the standardization to come up. So internally, we're using ultra-wideband technology for that. But the fourth element, which also has a lot of investment, people are investing heavily in that, it's a digital twin. And again, that's the data part to build up a model of your factory, so that you can do in all kinds of simulations, but you also know what's really happening all over the place. But if people are investing so much in AR and VR, it's really about the interaction between the human and the machine. But why are people doing that? Why is the manufacturing industry investing so heavily? And in my opinion, the manufacturing industry, at least in the Netherlands, is investing very heavily in it, because there aren't that many people that want to work in that environment. They are actually not there anymore. And sometimes when they're there, you need long training cycles in order to do that. And if then the attrition rate is low, people leave the company quite rapidly, you need to do something with automation, etc. Or you need to do something with reducing the waiting time that operators sometimes have in order to work in that particular factory. So you need to scale out. But if you really want to do that, you need to have the right interaction between the machines, the very complex machines, and the human. Next, we'll come with a short video where we explain how we're doing that. So hopefully you understood and remember afterwards, it's about people are in the manufacturing industry are very heavily investing in the connectivity. But you have to do it with a couple of partners. So you have to bring up a development environment in order to do that. And that's what I'd like to show, the ecosystem and the development opportunity. 2 use cases. One of them, the first one, is the handling of a very complex machine. In this case, it's an example, but you can do it extrapolated to a very complex machine with help of a HoloLens, but also with the help of a low-code data application. Because sometimes a lot of these people see the data, but how to interact with the data. And the operation of the machine should also be based upon what's in the state of that machine. And we'd like to give the operator all the data so that he knows what the status of that particular machine is. And that's what you see in the video. The second part is a small robot, and you will, at the GSMA stand over there, you will find that robot, so please visit us, etc. That robot is not a fancy one, but that robot has all the development characteristics so that we can bring the ecosystem together, experiment, and look for what are the real problems of that manufacturer so that we can solve these real problems. So it's really business first, technology second. Now, I talked a lot, so let's see what the people in the movie are going to tell us.
Human-machine interaction is, in essence, a way to help people and machines cooperate more intensely.
We work together with small and bigger companies like KPN and Cordis, and they work together with their own expertise and make an integrated solution.
This is the HoloLens. I'm placing it on top of my head. I switch it on, and then I see the augmented reality dashboard in front of me, and you can interact with the machine. And on the left side, you can really see the technical details. For this use case, we use several technical building blocks, a low-code machine platform, the HoloLens, and the 5G that connects both of these elements. What you see here is an autonomous driving robot, which uses visual wayfinding via its cameras. So on top of this robot, we have these cameras and these sensors. They gather all kinds of information. They are connected via 5G to an edge computer. This is a good example for manufacturing and logistics because it enables a robot and a human to work together to keep an eye on a large indoor environment.
Hopefully you saw on the left-hand side of the screen that state diagram, which was used by that operator, or my colleague in this case, Paul, to switch on certain parts of that sorting machine we were experimenting with. And the second example, you saw the interaction with the robot and the machine, where you could count people, but also show up people and then say, okay, robot, please stand still, because otherwise you're bumping into somebody else. And as I'm a techie, I always want to have some technology picture in it. This is actually the setup that we use in Brainport Industry Campus in Eindhoven, which is the environment in the Netherlands where a lot of the manufacturing developments, but also the manufacturing takes place. We have an office in that facility so that we have the whole ecosystem around us, using a 5G edge environment over there, but also use ultra-wideband for precise localization, which is also important data stream to be used. In that, we think we can develop a lot more and bring everything together so that finally, as last slide, we can boost production together with these people in the manufacturing industry, using our 5G and high-quality network. We can also reduce the downtime by using the data in a proper way, and I think, Guan, you already worked on that as well. But more of it, we can use the virtualization, and that's not the virtualization in the computer and the data side, it's the virtualization of site, how people interact with the machines, so that you can scale out a lot of these functionalities in a much broader way. And I think this is absolutely necessary to help the manufacturing industry to make the steps that they need to make with the scarce population and the scarce amount of people that want to work in that environment. I hope I have inspired you a little bit, bringing the ecosystem together, use 5G, The manufacturing industry is willing to invest in that. So I hope that in this audience there are a lot of people that want to cooperate with us and bring even better solutions to help boosting the productivity. Thank you very much.
Thank you. Thanks very much to Jakob for that fantastic insight. And we're going to our last session within session number 1 today, and I'm going to hand back to Lan, who's going to introduce the panel.
Oh. It's not working. Yeah, I know, yeah. All right, we need to move to the next slide so I can introduce the panel list here. All right, so we're back to the stage here. I'm very excited to be hosting the panel discussion. So we have a couple of very esteemed panel members here. Let me start from Nadine.
Hi.
Yeah, can we go to the next slide?
Are we introducing ourselves?
I know Nadine's from Teradata.
Right.
Yeah, why don't you introduce yourself?
So good morning, everyone. I'm Nadine Manjaro. I'm a director at Teradata, doing data analytics, working mostly with the telecommunications companies in the US.
Okay, thank you. Dr. Jordi from ABB.
So thank you, Len. I'm Jordi Artigas. I have 2 roles at ABB. I'm chief engineer for mobile robots in our R&D organization at ABB, and I'm also global technology manager for one of our business lines in robotics, which is called consumer segments and service robotics.
Thank you. Laxmi?
Laxmi Akkaraju from Cognite, so Senior Vice President of Strategic Services. And Cognite is a company that works in the space of industrial data operations, which you talked about earlier today, Lan.
Wonderful. And last but not least, Phil from...
Good morning, everyone. Phil Skipper, I'm the head of strategy for Vodafone's IoT business. I'm pleased to be here for 3 reasons. One is I come from a manufacturing background. 2 is we run our own Industry 4.0 factory ourselves. And 3, as the leading IoT provider, I think we generate most of the data that drives AI going forward. So a pleasure to be here today.
Fantastic. So let's jump right in. Let's start having some fun together, okay? So can each of you, in 1 to 2 sentences, very briefly describe an exciting technology or catalyst that is playing a pivotal role right now in AI and robotics in manufacturing? Maybe we start from Nadine.
So many of the manufacturing companies are looking at predictive analytics and how they can use machine learning algorithm to predict, say, failure. Or so, for example, large automotive companies are looking at it to look at paint, for example, to detect anomalies in the paint, because that would cause rework. So they want to find those problems before the vehicle reach the end of the manufacturing process and then have to rework the entire thing. So they're using predictive analytics to look at how to detect deficiencies in the paint, as well as in spot welding. So that's just one use case that we've seen.
That's wonderful to hear. I'm so glad that I'm not the only one who likes the cars example. Yeah. All right, Dr. Jordi.
Yes, we are in year 2022. And the truth is that robotics still haven't reached that level of penetration that was predicted many years ago. We heard many times gurus telling us in the next 5 to 10 years we're going to see robots in our homes doing, our laundry and emptying the dishwasher, and that cars would be fully assembled by robots. Today we have catalysts in manufacturing and logistics. Probably those are the main ones, and they are greatly benefiting from technologies and methods like artificial intelligence and machine learning, cloud computing, or cloud robotics, as we call it in the field, and 5G. And those are really bringing us closer to those visions that were set many years ago. And I can tell you that ABB is already one of the key players. And exciting days in front of us, and looking forward to diving in the discussion.
Okay. Laxmi, what are your picks?
Yeah, so what I'm really excited about, both for factories and a lot of other areas, is the operational digital twin. That's kind of taking it one step up, right? I mean, the backbone of an operational digital twin is a unified industrial data model. And that's really pulling together like all the data from the IT systems, the control systems, the operational data, maybe even the engineering drawings. And when you pull all this data together, you're able to create a really visual and immersive version of your asset or your factory or whatever. And that can really be used as a basis for a whole bunch of analysis, right? Whether it's predictive maintenance or controlling the operations, production optimization, research, innovation. So operational digital twins is what I'm really excited about.
Wonderful.
Yeah, from my perspective, I think there's actually three things coming together at the same time. So the first one is really the availability of high-quality visual technology. So this is mostly low-cost video sensing. I think the second one is the availability of really reliable communications. And I think the third one is the availability of low-cost compute power, either at the edge, on the device, or in the cloud. And I think when we look forward in terms of industrialization and automation within manufacturing, it's those three things that are really going to change the game.
That's great to hear. Okay, so this brings me to the next question. I will ask Dr. Jordi first. Okay, so many people may have this preconceived notion that robots are able to do everything automatically. They're so great, right? But the singular robot needs to be pre-programmed to do tasks. This is where cloud robotics can break that limitation for a shared brain. Can you expand how cloud robotics is able to enable distributed intelligence and and talk a little bit about their benefits?
Sure, Len. That's a great question. And let me start with a comparison. Since we are in the Mobile World Congress, if we look at iPhones today have thousands, millions of apps. And the reasons why, one of the reasons why there are so many apps for iPhones is that the tools for developers to develop new apps are at the hands of almost anyone. They are simple to use, and that has made a major breakthrough in the iPhone and Android development. In robotics, it's slightly different, right? If you want to program a robot to do a simple task, such as grasping an object and bringing it from A to B, there are already some associated challenges because you have to deal with physics, when motion and dynamics, kinematics. So it's not so straightforward. If you want to generalize and make this task abstract so that you can pick any item and bring it into any location, then this could already be a PhD topic, right? But today, thanks to machine learning and artificial intelligence, there is the possibility to program robots without typing a single line of code, right? So through learning algorithms, the robot can learn how to do things. You basically need to define a function, an analytical function or a numerical function that describes the goal of the task and let the robot do the learning until it reaches that task. So which are the key ingredients to enable something like that? Well, first of all, learning in synthetic worlds is a good idea for the simple reason that if you learn something in a virtual environment, you can break anything, right? So that is, there's already a lot of potential on that. And the second reason is that you can speed up the learning process drastically because you could set up 1,000 synthetic worlds with 1,000 virtual robots learning in their own virtual environments. And as long as you share the learning among those 1,000 virtual robots with each other, and they all contribute in optimizing the cost function, then you greatly can speed up the learning process. The second key ingredient to enable something like that is a cloud infrastructure, right? The cloud is the vehicle that allows you to implement those 1,000 virtual environments. And if you think of metaverse, right? So you could use something similar like metaverse, but instead of having human avatars, you could have virtual robots that could learn in those virtual environments. This is actually already happening. You mentioned Omniverse from NVIDIA, Isaac. There are already great simulation tools, photorealistic with physics engines that allows to do this kind of learning. And finally, through learning and virtual environments, eventually you will get the program, right? And this program needs to be executed somewhere. Classically, we would run this program in the robot controller, right? But today we can use the same cloud infrastructure to execute the program. We just need one more thing, which is the connectivity. We want to have a very high bandwidth because we want to stream sensor data. We also need low latency, right? Jitter should be the minimal, of course, and reliability. And this is actually the definition of 5G. So 5G is really an enabler for these cloud robotics ideas. So to sum up, cloud robotics has some great benefits. One of them is the fact that you do not need to reprogram individual robots because everything is on the cloud and the robot just executes whatever is in the cloud. But there's also other benefits. If we do something like that, the CPU hardware complexity can be drastically reduced because the robots become more dumb in a way. All right, they need to fulfill a minimum, of course, related probably to motion and safety, but most of the intelligence can be shifted to the edge or to the cloud. We just need the proper communication infrastructure, right? And the third benefit is that you were mentioning digital twins, right? So we can seamlessly switch between digital twins and physical twins, right? That has a lot of potential because you can do everything, all the design in the virtual environment, and at any time switch into the real environment to fulfill the task. So yes, very exciting days for robotics and connectivity, and yeah, stay tuned.
Okay, yeah, it's great to hear the three ingredients making up the cloud robotics: synthetic learning, cloud infrastructure, and connectivity. All of this speak to the volume of data and millions of AI machine learning models that we could be talking about. So let me turn to Nadine. So members of our audience are actually very curious about the telco impact such complex algorithms would create. As new edge native applications place more stringent real-time demands on the network, many enterprises will likely find the best path to path to edge transformation runs through their CSPs. Can you share what CSPs are doing to innovate their network to meet this kind of new demands?
So CSP is as in cloud service providers?
Yeah, exactly.
Okay, so the cloud service providers, they're deploying edge networks. You probably heard a lot about it. So they're pushing the infrastructure closer to where the application is actually being used. And so, you know, this is going to lower the latency for the applications to deliver, to enable faster response time for all your robotics. And so that's the key initiative. In addition to that, I think data analytics, we haven't mentioned that, but the data is critical for all of this to work. Within the factory, they're currently collecting a lot of data, but the data is siloed. So there has to be a central way of aggregating that data and enable end-to-end visibility across all that data to enable analytics to really be fully useful. And so I think that's one of the key initiatives. So the cloud service providers, like someone mentioned before earlier, I think you need the ecosystem. So as the cloud service provider, you need a strong data analytics company. This is where I'm going to put a plug for my company. This is where Teradata comes in. We've been doing this for over 40 years. But that's going to be a critical part of it because the data, again, at the end of the day, if the data is not centralized and you cannot aggregate the data and use it across visibility across all of the different sources, then you won't be able to enable this automation. So that's one of the key things, I think, that we want to mention.
That's great to hear. I will be talking to you offline about some new innovation from Teradata. So data. Both Joachim and I keep mentioning the importance of data in this topic. So let's turn to Laxmi from Cognite. I was actually using the data fusion example in my talk earlier. So as data in manufacturing facilities often generated is in disparate sources, we talk about many examples, right? Sensors, meters, control systems, and now even robots in the cloud. What is your advice for smoothly consuming and executing on the sum of the insights from these sources? What are some cool things that Cognite is doing to help solve these kind of challenges?
Yeah, I think I'll just build off of what Nadine has just been talking about as well. Data, 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 right? I mean, it's all the data that you talked about from the manufacturing floor. And, manufacturing is so complicated as well because out there on the factory floor, you've got assets that have come from multiple generations. A lot of things are being done in silos. There's a lot of lack of standardization. So really, we're getting data from all sorts of places, all sorts of data types. And, what you have at the end is a giant data lake. And how valuable is that? I mean, everyone is already using billions of dollars trying to collect all this data. So this is where I think like Cognite Data Fusion or an industrial data ops platform is very useful. Because what we try to do then is to ingest all of this data and contextualize it. And contextualizing data is really about creating relationships between the data and creating a more enriched data model. So you can think of it as kind of Facebook for industry. So just as Facebook has been very clever about collecting all of our data from all of these disparate sources and then being able to create a profile on us and predict things about you, we're trying to do that with industry, right? Collect the data from the OT systems, the IT systems, engineering drawings, pull together, use machine learning and AI to create these models. And then with this enriched data model, you have kind of a more unified source of truth. And if you add things like data governance, where you're keeping track of lineage, validation, and things like that, and also structured data process, where you have a really good way for getting the data from the data producer to the data consumer, then all these three things together, ingestion, contextualization, governance, and process, gives you a really good collaborative industrial data model. And with that, you're able to kind of really then get to insights that everyone can use, where people are looking at the same source of data and can really trust that data. So I think this is where this is really a valuable thing to do now with all the disparate data sources.
Okay, that's wonderful to hear. Data trust is one of the most important things. This leads me to the last question for Phil. One of the most important questions. So me growing up as a data scientist, I'm always take pride in the models I build, right? So this is the very important last 1% question. Just how much do we need to get right? Many companies are counting on a lot of improving algorithms to be the last 1 to 2% in manufacturing. Especially many startups out there are actually bragging that this is what they are really good at. So, Phil, do you believe it's worth the focus to on the last 1%? Should we leverage humans to solve the last step? What is your thoughts there?
Yeah, I think if you look at manufacturing, the last few percent are critical, but look, I think in the debate, we always talk about data, but knowing something is not as good as being able to deploy it. So what you have to do is to use the data, understand what it means, and then actually do something. And I think this is where AI and robotics comes together, because what we haven't opened up here is this is all about control. What 5G does, it brings low latency, it brings high bandwidth, and it brings quality of service, which means the network is now deterministic and you can control things. Be that robotics, AI, AGVs, cobotics, it doesn't matter. So I think you have to look at this as a control problem. So when I think about the last 1%, certainly for manufacturers, that's absolutely important, but do you need to have 99% of the data to get there? The answer is probably no, you don't. What you have to do is you have to have the operational assets in place to do it. So what we're discussing here are technologies. In manufacturing, you have to treat those technologies as an operational asset and run your business on that basis. So I think 1%, yes, certainly. Are we anywhere near the 1%? I don't think we are, because we're probably less than 1% on the journey towards the confluence of AI and robotics. And I think the third one is, if we're going to get there, we have to treat technology as an operational asset, not just technology for technology's sake. So I think my adage is quite simple. If I have to have somebody to interpret an actionable insight, they're probably clever enough to decide what the insight was in the first place. So unless you can couple them up, and that's where robotics, AI, and data come together, you're not going to actually unleash the power that these technologies will bring in the operational space, not just for the good ones, the big guys who are building new factories, but more importantly for the SMEs who are going to be able to punch above their weight by using technologies that they can employ quickly and simply across their manufacturing estate.
That's great to hear. So I want to thank all the panelists here, Phil, Nadine, Laxmi, Dr. Jordi. So this is thank you for all your insights around data, infrastructure, cloud, and everything. I look forward to seeing you guys in the next discussion. Thanks, everyone.
Thank you.
Thank you.
Thank you.